Assalamualaikum and hello everyone. My name is Muhammad Rafiq Haikal and today our topic focuses on the application of basic chromatography in food safety, especially the detection of artificial food coloring. Chromatography is an analytical technique used to separate, identify and analyze components present in a mixture. The separation occurs because different compounds interact differently with the stationary and mobile phase. In this study, thin layer chromatography or TLC was used. TLC employs a silica gel coated plate as the stationary phase, while a solvent acts as the mobile phase. As the solvent moves up the plates, different compounds travel at different rates, resulting in the formation of distinct spots. Detecting artificial food coloring is important to ensure food safety and protect consumer. It helps identify unauthorized or excessive use of synthetic dyes, ensure compliance with food regulation, and minimize health risks such as allergic reaction and hyperactivity.
Hi everyone, my name is Safia Hadiza and I will be explaining about the theories of basic chromatography regarding the detection of artificial food coloring. First, the principles. The separation process in chromatography occurs due to the different affinities of dye molecules towards two phases, which are stationary phase and mobile phase. In thin layer chromatography TLC, silica gel coated on a plate serves as the stationary phase, while the mobile phase refers to the solvent or solvent mixture that moves through the stationary phase by capillary action. As solvent travels through the stationary phase, individual dye molecules migrate at different rates depending on their polarity, molecular structure, and solubility. Dye that have a stronger attraction to the stationary phase moves more slowly, whereas dye with greater affinity for mobile phase travels further. As a result, mixture containing several colors can be separated into distinct colored spots. Positions of these spots can then be compared with known standards to identify the artificial colorants present in the food sample. Next, the RF value concept. The retention factor or RF value is used to characterize the movement of a compound during chromatographic separation. It is calculated using the equation shown. RF value ranges between 0 and 1. Value closer to 1 indicates that the compound traveled almost as far as the solvent front, which suggests a stronger affinity for mobile phase. Conversely, lower RF value indicates stronger attraction towards stationary phase. The RF value of unknown samples can be compared with those with known food dye standards. If the values are similar, the unknown dye can be identified. However, factors such as solvent composition, temperature, humidity, and stationary phase characteristic may influence RF value. For this reason, standard dyes should always be analyzed alongside the unknown sample to ensure accurate identification. Some of the most commonly used food coloring in food industry include tartrazine, E102, a yellow azo dye frequently used in beverages, candies, and snacks production, sunset yellow FCF, E110, and orange yellow dye commonly found in soft drinks, desserts, and processed foods, as well as Alorared AC E129, red color used in confectionery products, flavored beverages, and gelatin desserts.
Assalamualaikum. My name is Rabiatul Maira and I want to talk about application of basic chromatography. So what is the role in controlling food safety? So it is used to detecting pesticide residues, identify mycotoxins and toxins, and catching food fraud and adulteration. Next is the advantages, which is it has high stability unlike natural colors. It also far cheaper to mass product in a lab. They also offer vibrancy and variety, which is incredibly bright, intense hues that are difficult to replicate using natural ingredients, and it has low quantities. So for these advantages, it has zero nutritional value, masking poor quality, and it's free of regulatory hurdles. So for the risk of using artificial food coloring, it can cause hyperactivity in children, allergic reaction and sensitivities. Also can cause carcinogenic impurities, and it can create a gut microbiome disruption.
Moving on to the methodology of basic chromatography to detect artificial food coloring. First, sample collection and preparation. Food samples containing artificial coloring, such as colored beverages, candies, or jellies, were selected for analysis. A small amount of each sample will be dissolved in distilled water and filtered to remove insoluble particles. In addition, prepare standard solutions of common artificial food dyes including tartrazine, sunset yellow, and allura red AC. These standards serve as reference compound for comparisons and identification. Next, the TLC procedure. Use a TLC plate coated with silica gel as the stationary phase. Draw a pencil line approximately 1 cm from the bottom edge of the plate to mark the origin. Using a capillary tube, apply small spots of the prepared food sample and dye standards onto the origin line. Allow the spots to dry completely before development. Then, place the TLC plate in a developing chamber containing an appropriate solvent system. Ensure that the solvent level remain below the sample spots. Cover the chamber to allow solvent vapor saturation and to promote uniform chromatographic development. As the solvent moves upward through capillary action, the dye molecules will migrate at different rates depending on their interactions with the stationary phase and their solubility in the mobile phase. Lastly, observation and data analysis. Visually examine the separated dye spots and measure their migration distance. Compare the obtained RF value from the food sample with those of the standard food dye. A sample spot showing a similar RF value and color appearance to a standard dye can be identified as containing that particular artificial food coloring.
Okay, so in this slide, I will show an example of TLC result for the detection of artificial food coloring. After the analysis, several color spots appears on the TLC plate. Each dye travel different distance due to differences in their interactions with the stationary and mobile phases. The RF value obtained were 0.60 for tartrazine, 0.69 for sunset yellow, and 0.51 for allura red. These RF values were then compared with standard reference values. When the obtained RF value matched the standard values, the presence of specific artificial food dyes in the sample can be confirmed. Therefore, thin layer chromatography (TLC) is a simple, rapid, and reliable technique for detecting artificial food colorings and ensure food safety.
For conclusion, chromatography techniques ranging from basic thin layer chromatography to high performance liquid chromatography serve as an essential cornerstone in food safety by enabling the precise separation, identification, and quantification of artificial food colorants in complex food matrices. While synthetic dyes are widely used in the food industry to enhance product appearance and consumer appeal due to their low cost and high stability, strict strict legal threshold and potential toxicological risk demands rigorous monitoring protocol.